Welcome friends to Raindrop Academy. We are doing chapter 2 of class 9, that is polynomials. And in that we have done 4 sessions. And in 4 sessions, I will just go for a quick recap what all we have done in that 4 sections. And for detailed, you have to go to those earlier videos, go through it, and it is very important. I will advise you that before seeing this video, you should stop and you should go to the first 1, 2, 3, 4 polynomials 4 videos. Anyway, I will just do the recap. Okay, so what all we have read? First, we have read what are polynomials. Polynomials are algebraic expressions. So for being an algebraic expression, it should have a constant like 2, 3, 4, and a variable part x, y, and z. So friends, like 2x plus 3 or 2x square plus 5 plus or 2x square plus 3x plus 6 is a polynomial. Why? Because by definition, it is an algebraic expression with the degree of the this polynomial should be a whole number. Okay, it should not be a fraction or it should not be a negative number. So what is the degree of that polynomial? Now the word comes degree. Degree is nothing but the highest power. Like in 2x squared plus 5, the degree is 2. In 3x cubed plus 2x squared plus 3, the degree is 3x cubed. So x is 3 is there. So 3 is the highest power. X cube is x to the power of 3, so the degree is 3. So based on the polynomials are categorized based on number of terms: monomial, binomial, trinomial. Means monomial means one term, two term binomial, and three term trinomial. And based on the degree, that is linear, quadratic, and cubic. So linear polynomial examples are like x plus 3, x plus 6, which has a degree 1. Variable part, here x is the variable part and it has a degree 1. Similarly, the quadratic polynomials are in the form of ax squared plus bx plus c. Example, like x squared plus 3x plus 2. This is a quadratic polynomial. And what is a cubic polynomial? For cubic polynomial, it has to have a degree of 3. I already told x cubed plus x squared plus 2 is a cubic polynomial. Now, then after that, we read about the different values of the polynomial by putting the different values for x. Say the polynomial in x is x cubed plus x squared plus 3. If we put -1 in place of x, we get a different value. 2 in place of x, we get a different value. Similarly, we went ahead and we read the zeros of a polynomial. What are zeros of a polynomial is the value, if we put it in place of x and we get a 0 in when we put in place of x in the polynomial and we get a 0 is the zeros for that polynomial. Then we read about how to divide a polynomial. Okay, so we have done this in 1, 2, 3, 4. And after that, we read about the remainder theorem. Remainder theorem says that, suppose I will just write it down. Okay. Okay, sorry, it's not connected. I'm just connecting it, my friends, and then we will be ready to go. Okay. Now it is connected. So we will go and we'll learn it. Okay. Sorry for this disturbance. So we said that we will be reading the remainder theorem. Remainder theorem. We have read it. Theorem. So what it says, if a polynomial say px, which is divided, and here the degree of this polynomial should be greater than or equal to 1, and when it is divided by a polynomial, linear polynomial x minus a, you get a remainder is p of a. Fine. P of a, you just put it like this. Okay. Now if we see conversely, that if the polynomial is a factor, suppose this polynomial is factor of px or not, suppose is only the factor when p of a, when you put a in place of x in this polynomial, suppose the polynomial is x cubed plus x squared plus 1, and you put a, like a is -1 or whatever, and you get a 0, then this is a factor of the polynomial. Fine. So these things we have read it. Now today what we are going to learn. Today what we are going to learn is further in that chapter, and it is factorizing the polynomial by splitting the middle term, which you have already learned in previous chapters. Factorizing the polynomial, that is a quadratic polynomial for an example, and by splitting the middle term. So we take an example and we learn it. Quadratic polynomials of degree 2. So say x squared plus 5x plus 6. This is a quadratic polynomial because degree is 2. Now middle term is this. Okay. And so what happens? We have to split this middle term in such a way that suppose we are splitting it in p and q. So p plus q should give you 5 or 5x. And p multiplied by q should give you 6. That is ax square. Here a is 1 into c. C is the constant. So anyway, if you are not understanding, no problem. We will solve it and we'll learn it. So here we'll split the middle term. So middle term is split like this: 3x plus 2x plus 6. Okay. Now we take this common: x plus 3 plus 2 into x plus 3. Now you see this x plus 3 is in both the sides. So we take x plus 3 out, x plus 3. Okay. This type of bracket I am using. So what you get, this x here plus 2. But this is equal to. So once we are factorizing the above polynomial, we can factorize it to this level. This is very important because by this you can get the roots for the quadratic equation. What are the roots? Which give you the zeros for this quadratic equation, or it is the answer. So anyway, this is for the polynomial in the form of ax squared plus bx quadratic polynomial c. So what is the how we do the splitting of middle term? P plus q. Suppose we are splitting in p plus q. So we should get b, and pq, that is p multiplied by q, should be ac. Since a is 1 here, so we get 6. AC is 1 into 6 is nothing but c. Now we take a polynomial which has a more than 1. So we will take for example and then we will solve it. So we take this polynomial 6x squared plus 17x plus 5. What is this? Ax squared plus bx plus c form. Okay. This is the form. So by splitting, we should get p plus q should be equal to 17x, and p multiplied by q should give you 30. Fine. So you see, there are different combinations. 6 and 5 is a combination. Then you remember any other combination. 10 and 3 is also a combination, but 10 and 3 will not give you 17x. So just go for more higher. So if you take split this as 15 and 2, you will get 15 into 2 is 30, and 15 plus 2x is 17x. So split it like this: 6x squared plus 2x plus 15x plus 5. Okay. Now you take 2x as common, you get 3x plus 1. Here 5 as common, then you get 5 into 3x plus 1. Purpose is to get similar things inside the bracket. Fine. So now you can take this as common: 3x plus 1 into 2x plus 5. Fine. So this is the factorizing the above polynomial is done like this. Got it? So here the a was not equal to 1. Ideally, we have seen it was mostly it will be 1. Not ideally, mostly. But here if it is more than 1, so the product should be a into c. Fine. Now we go ahead in the chapter. We solve few questions. Chapter means 2.4 exercise. 2.4 exercise, if we go and solve the first question. What is the first question? You can open your NCERT course book and see the first question. So first question is, determine which of the following polynomial has x plus 1 as factor. I'll write it again. X plus 1 as factor. We solve the question number 1. The polynomial is x cube plus x squared plus x plus 1. Okay. So x plus 1 to be factor is x minus a form. First you write x1, x plus 1 can be written in the x minus a form as like this. Since it is plus, so minus into minus becomes plus. So when you put this a, a is here equal to minus 1. A is equal to minus 1. So if you put minus 1 in place of x, if you get a 0, then x plus 1 is a factor. So what you get here, minus 1 cube plus minus 1 square plus minus 1 and then this constant 1. So this is minus 1, this becomes 1 plus 1. This is again minus 1 plus and minus. So this is minus 1 and this is constant 1. So now you see this will cancel, you get a 0. So it means once you are getting 0 as the remainder, it means this is the factor. So x plus 1 is factor of this polynomial. Okay, similarly you solve. There are 4 questions given. You solve. If there is any doubt, you can ask me. Now, use the factor theorem. Determine whether gx is the factor of px. There are gx and px. So again, I will say this question is same to the problem we have solved just now. In this, you have to put f of a or p of a. A is in second question. In first question, it is x plus 1 is the gx. So a is minus 1. In second question, gx is x plus 2. So a is x of minus 2. So once you put minus 2 in the polynomial and if you get a 0, then it is a factor. Otherwise, it is not. Okay. Now, find the value of k if x minus 1 is factor of px. Very interesting question. We'll solve. Again, it is based on the same thing. X minus 1 is the factor they are saying. That is problem number 3. X minus 1 is factor. So, find k. What is the polynomial? Polynomial, suppose we take the question number 1. Polynomial is 12x squared minus 7x. Sorry, this is not the question. The question is x squared px is equal to, we'll write it here. Px is equal to, this is the question, x squared plus x plus k. So what they are saying, x minus 1 is a factor. X minus 1 is a factor of this polynomial. So we should get a 0 when we put 1 here because x minus a form. So you put this equation from this equation, minus 1 to the power of 2 plus minus 1. In place of x, you are putting minus 1 plus k should be equal to 0. Then only it is factor. Otherwise, it is not factor. So you get 1 minus 1 plus k is equal to 0. So this becomes, so k is equal to 0. Okay, so in this question, the k will be 0. Similarly, you solve the other questions, and if there is any doubt, we'll get back to your doubts. Now we solve the fourth question. Fourth question is, we'll solve one, rest you have to solve it yourself. Factorize. Factorize one we are solving. This is question number 4, chapter 2.4. 2.4 polynomials. Okay. So question number 1. What is the question? 12x squared minus 7x plus 1. You have to factorize by splitting the middle term. Okay. So this is the question, 12x squared minus 7x plus. So what should we get the product? Product should be P into Q should be giving you 12 and P plus Q should give you 7. Okay. So you see here 12x squared minus 4x minus 3x, 7x can be written, and minus 4 into 3 is 12. Okay. So, sorry, this is minus here. Plus 1. Fine. So now you take 4x common. What you get? 3x minus 1. And if you take minus 1 here, you get 3x minus 1. Why? Because this thing can be taken common. So 3x minus 1, when it's taken common, you get 4x minus this one. So answer is equal to 3x minus 1 into 4x minus 1. So once you multiply, you will get this polynomial. Okay. First term, you will get multiplying these two, you will get the first term. So this is solved. Now you solve the other three problems. And after that also it is factorize. Factorize, suppose x cube minus 2x square minus x. So this is a cubic polynomial. I will solve one. And then I will ask you to solve the other. And if there is any doubt, we'll get back to you. So this question is factorize x cube. Question number 5, 1. 2.4 exercise x cube minus 2x square minus x plus 2. You have to factorize 2x square. Sorry. 2x square minus x. Okay. So now you see this is a cubic polynomial. How to solve it? So we have to suppose first we take this x square as common. What we get? X minus 2. Okay. And here we take minus 1 as common. So what we get? X minus 2. Why? We have to get this x minus 2 inside the bracket. Now we can take, this is the second step. Third step is x minus 2 is taken as common. So we get x square minus 1. We can leave it here also, but this is still not factorized. Okay. This can be, this see, it is in the form of a square minus b square. So you remember this is nothing but a minus b into a plus b. So you can write this is already factorized to the lowest term. This can be factorized as x plus 1 into x minus 1. This one, we have applied this identity. So this eventually the polynomial becomes x minus 2 into x plus 1 into x minus 1. Okay, this is your answer. And I will ask friends to do the remaining problem. And if there is any doubt, you can surely get back to me. I will clear your doubt. Thank you, friends. Have a nice day.